What's up, calculus students? Recording this video at the end of our first day of school. So look, it's Wednesday. So you see, I do this stuff for you. I was going to record it tomorrow, but I have a department chair meeting. So got to get it in today so that you guys have it for tomorrow. All right, here's your first homework. We are doing finding locations of angles and then trig function of the angle location. That's it, simple. But we got to be able to find these locations without any additional help. I don't like to take this and transfer it into degrees. I just like to remember pi over 3 is like anything with a pi over 3, that's talking about a 60-degree reference angle. And anything with a pi over 6, that's a 30-degree reference angle. Pi over 2, 90. And again, how do I know this? 360 degrees corresponds with 2 pi radians. Circumference of a circle is 2 pi r. When r is 1, we have a unit circle. So the circumference of a circle is 2 pi, units. So 360 degrees all the way around the circle. It's the same as 2 pi units. And then you just start dividing. Divide that by 2. 180 is 360 divided by 2. Means that's pi. Divide this in halves. Sure, let's divide this in halves. 90 degrees is pi over 2. Divide this by 3, you get 30 degrees is pi over 6. Which means, like, if you add 30 degrees, that's like adding pi over 6 to pi over 6. It's 2 pi over 6. 6 degrees ends up being 2 pi over 6, which is pi over 3. Okay, if you work your way around, every single pi over 3 is a 60-degree reference angle. We just got to figure out where it is. Every single pi over 6 is a 30-degree reference angle. Just got to figure out where it is. And then take this divide by 2, you get the whole 45 degrees. 90 divided by 2 is 45. Pi over 2 divided by 2, or times a half, is pi over 4. Okay, so let's find it. Again, this is 0. We add by going counterclockwise. We subtract by going clockwise. 6-degree reference angle, that would be right here. Write the reference angle created with the x-axis when needed. Sure, this is 60 degrees. So that creates our 30, 60, 90 tall triangle. 30 degrees, starting at 0, adding 90 degrees, this is a 90-degree reference angle. How do I know 3 pi over 2 is over here? That's a great question. Okay, well, any pi over 2 is 90. Let's think about this. 1 pi over 2, 90 degrees. Add a pi over 2. 1 pi over 2, 2 pi over 2, 3 pi over 2. That puts us right here. 5 pi over 6. Okay, this is when we start after worrying about, like, where are we located? Okay. All right, well, if this is 0, this is where we start. And if we go around our circle counterclockwise, this is pi, this is 180 degrees. Keep going around. We get back to where we start, 360 degrees around our circle to 2 pi. And we can keep going. We might end up at the same locations where we were before, but we'll have different angles. It's like spinning around in the X Games. The more you spin around, you get different angles, but you might end up facing in the same direction. Okay. Now, I use this and this to help me locate angles by saying, okay, well, let's rewrite things. You know how you can take a number like, I don't know, 1 and write this as like 3 over 3, or you could write 1 as like 6 over 6, right? Well, we're going to take pi and rewrite it. You can write this as 3 pi's over 3. 3 divided by 3 is still just 1, so pi is just pi. You write this as 6 pi over 6. You can write it as 4 pi over 4. So it's important to know, like, how this can be written differently. Why does that help me? It's like, okay, 5 pi over 6 is 1 pi over 6 less than 6 pi over 6. if going counterclockwise is adding and going clockwise is subtracting. That means if I go counterclockwise, I'm adding. If I'm going clockwise, I'm subtracting. I need to go 1 pi over 6, or 30 degrees less than pi to get to 5 pi over 6. 6 pi over 6 minus 1 pi over 6. Puts me right here. 30-degree reference angle. Why? Because it's a pi over 6, creating my short 30, 60, 90 triangle. Okay? 5 pi over 3. Two ways to do this. You can start here at pi, which is the same as 3 pi over 3. Now, if you start at 3 pi over 3, you realize that this, adding 60 degrees, adding a pi over 3, gets you to 4 pi over 3, which means you need to add another 60 degrees to get to 5 pi over 3. Puts you in this quadrant. You have to add 120 degrees. Or let's say we take 2 pi. 2 pi is all the way around the circle. Well, just like 2 is 6 over 3, or 12 over 6, or 8 over 4. If I want to put it in terms of pi's over 3, 2 pi is the same as 6 pi's over 3. Okay, same deal. Subtracting going this way, adding going this way. Start at 6 pi over 3, subtract a pi over 3 to get to 5 pi over 3. I'm right here, creating a 60-degree reference angle. This is 5 pi over 3. Tall 30, 60, 90. 3 pi over 4, I got 4 pi over 4. Subtract a pi over 4. Again, 4 pi over 4. Subtract 45-degree reference angle. Good. Pi, we already know it's 180. It's over here. Okay, 4 pi over 3 we haven't done yet. This is the case when we'll go to pi. Understand that pi can be written as 3 pi over 3. We then add a pi over 3, which is adding 60 degrees, putting us here, and creating a 60-degree reference angle right there. Same thing with 5 pi over 4. We'll start over here at pi. We know we can write that as 4 pi over 4. And again, adding counterclockwise, subtracting clockwise, putting us at 5 pi over 4, 45 degrees. Just wrote 55. Seven pi over 4. You can start at 4, and then you got to go 5, 6 pi's over 4, which is 3 pi over 2. 7. Probably easier to start at 2 pi to know that that's 8 pi's over 4. Adding this way, subtracting this way, subtract 7 pi over 4 right there, 45 degrees. Negative 2 pi over 3. Well, if this is 0 and you start going this way, that's a negative direction. Puts this pi also at negative pi. Okay, that's negative 3 pi over 3. All right, let's be careful. Adding goes this way, subtracting goes this way. And this is adding goes this way, subtracting goes this way. If I'm at negative pi, that's like negative 3 over 3. Do I add or subtract a pi over 3 to get to negative 2 pi over 3? I add a pi over 3, right? Negative 3 plus 1 is negative 2. So you don't want to keep going up, because that'll be subtracting and put us at negative 4 pi over 3. It'll be right down there at negative 2 pi over 3. You'd also start at 0, negative 1 pi over 3, negative 2 pi over 3. 60 degrees. 7 pi over 3. That's bigger than 2 pi. 2 pi is 6 pi over 3, right? You can write 2 as 6 divided by 3. You can write 2 as 12 divided by 6. Okay, I'm going to add 1 pi over 3. I get here. It's the same location. We call it coterminal to 7 to pi over 3, but it's a different angle. 7 pi over 3 means you go around the circle completely, and then you go 60 more degrees. Negative 13 pi over 4. What? It's very close to negative 12 pi over 4, right? And then maybe we'll have to add another negative pi over 4. That's a good way to write things, like 7 pi over 3 is 6 pi over 3 plus 1 pi over 3. 4 pi over 3 is 3 pi over 3 plus a pi over 3. I'm going to do this tomorrow during the lesson. 5 pi over 4 is 4 pi over 4 plus a pi over 4. 7 pi over 4 is 8 pi over 4 minus a pi over 4. Right? Maybe that helps you if you do that. Try it. All right, well, negative 12 pi over 4, 12 divided by 4 is 3. So I got to go to negative 3. Negative 1, negative 2, negative 3. So this is negative 3 pi. And then I need to, let's see, this is add. So this is add. This is subtract. Subtract a pi over 4. So that puts me right here. Negative 1, 2, 3, and another pi over 4. 45 degrees. This looks like it's 17 pi over 6. Let's see. How can I add or subtract just a pi over 6? I can start with 18 pi over 6. Subtract a pi over 6. 18 pi over 6 is 3 pi. 1, 2, 3 pi. But subtract a pi over 6. Boom, right there. 30 degrees. Negative 5 pi over 2. I like to just work my way around. 1 pi over 2. 2 pi over 2, right? 2 pi over 2 is the same as just pi. 3 pi over 2. This is negative 3 pi over 2. Negative 4 pi over 2. That's the same as negative 2 pi. So this is negative 5 pi over 2 down here. 90 degrees. All right, now find location, draw the triangle, simplify and rationalize all fractions for practice. Go. I don't have you draw the triangle, but I'm going to do it. Okay? Cosine of pi over 4. So pi over 4, 45 degree angle. This is a unit circle, so that means this radius is 1. When a radius of 1, the side lengths are root 2 over 2 and root 2 over 2. So 45, 45, 90. You can use the Pythagorean theorem to prove that. In so, ka, toa. Cosine is the adjacent. Since cosine of an angle is adjacent over hypotenuse, and because the hypotenuse is only 1, we're just looking at the adjacent side length. And since we're always using a reference angle with the x-axis, adjacent is always the x distance. X distance is this root 2 over 2. Sine pi over 3. Pi over 3 creates a 60 degree angle. This is our tall oriented 30, 60, 90 triangle. Tall oriented 30, 60, 90 triangle has the shorter side, which will be the horizontal side, and the longer side, root 3 is bigger than 1. Square root of 1 is 1. The square root of 4 is 2. Root 3 is somewhere in between. That's going to be the vertical side. Again, the hypotenuse is 1. Well, sine of an angle is opposite over hypotenuse. Since the hypotenuse in the unit circle is always 1, sine is just the opposite. Well, since we're always talking about a reference angle with the x-axis, the opposite is always the y distance, the vertical distance. Let me write this down a little better. Cosine is adjacent over hypotenuse, which is just the adjacent over 1, which is just x distance. Okay, so sine opposite y distance root 3 over 2. Tangent op over adjacent, neither of which are always going to be 1, but will always be the vertical distance divided by the horizontal distance. Okay, pi over 6, 30 degrees. Here's my 30, 60, 90 short triangle, where now this root 3 over 2 side is the horizontal side, the 1/2 is the vertical side. Opposite would be 1/2 over root 3 over 2. We know that when you're dividing fractions, it's the same as multiplying by the reciprocal of the denominator. Take your numerator, multiply it by the denominator flipped. We know that you can multiply these fractions straight across, but that you can't multiply the 2 by the root 3, so it's just 2 root 3. You know that when you do that, and since you just have multiplication, you can cancel those 2's, leaves you with 1 over root 3. That's one answer. But we also know, for the purposes of making things look consistent, that you can rationalize. This is what must be done if you didn't have a calculator, if you wanted to approximate what 1 divided by the square root of 3 is. You don't want to do that. You don't want to divide by a crazy decimal. You want to take a crazy decimal and divide it by a number. So that gives you root 3 over 3. I'm sorry this is so busy. I could probably zoom in more. Yeah, I think this will be better. All right. Sine of 5 pi over 6. All right, so I got 6 pi over 6 over here, which is pi.
Your signature on
Yeah,
this
just
one.
stay out of the video.
Sorry.
You're fine.
I think it's the other side. And it's over a unit circle.
Yeah. You'll get the video and the homework video online.
Okay, thank you.
Yep. All right, so 6 pi over 6, subtract a pi over 6, puts me right here at 5 pi over 6, 30 degrees away, creating my shorter 30, 60, 90 triangle. Vertical side length, I'm going up, so it's positive. Longer side length, I'm going to the left, so I'm going to say this is negative. This helps me. Sine, opposite always vertical, boom. 4 pi over 3, well, I know where 3 pi over 3 is. Add a pi over 3. That goes down here. Pi over 3 is always a 60-degree angle. So there I am. So tall, short side, long side. I'm going to the left from the origin. I'm going down. That's why I write that as negative a half and negative root 3 over 2. Cosine, adjacent, x distance, negative a half. And then pi over, yeah, root 3 over 2 right there. Okay. 7 pi over 6. Go to 6 pi over 6. Add a pi over 6. This is how we do it. Why do I know that it's adding this way? It's because counterclockwise is adding, clockwise is subtracting. So I'm right here, 30 degrees, creating my short 30, 60, 90 triangle. Going to the left, going down. I have both negative x distances and a negative y distance. Tangent opposite over adjacent. So it's going to be negative 1/2 divided by negative root 3 over 2. Negative divided by negative is a positive. Maybe you remember that. It's 1/2 times 2 over root 3. And again, I'll show you this is the same as 1 over root 3, which is the same as root 3 over 3. Root 3 times root 3 is root 9, which is just 3. Cosine 11 pi over 6. I'm over here. 12 pi over 6 is all the way around the circle. Subtract. Remember, subtract is going clockwise. It's not going up or down. It's going counterclockwise is adding on with angles. Clockwise is subtracting with angles. Puts me right here. 30-degree angle. Adjacent. Longer side. Vertical. Horizontal side. Vertical. Shorter side. Cosine. Adjacent. Always the x distance. X distance is root 3 over 2. 2 pi over 3, I can go to 3 pi over 3. I can subtract, always clockwise, adding, counterclockwise. Start at 0. Remember, like looking at 0, looking up is like adding an angle. Looking down into the ground, up into the sky is adding, down in the ground subtracting. So 2 pi over 3 right here, 6-degree angle. Longer side is going to be this side. The shorter side is going to be this side. I'm going to the left, which is why this is negative, but I'm going up, which is why this is positive. Sine, opposite, vertical, root 3 over 2. Tangent, 5 pi over 3. 5 pi over 3 is over here. How do I know that? 6 pi over 3, subtract a pi over 3. You get to 5 pi over 3. Tangent, opposite, I'm going down over adjacent. Longer, taller triangle, shorter, skinnier side is the adjacent side. Opposite over adjacent. Twos cancel. It's 2, negative 2 root 3 over 2. We're good. All right, we got some reciprocal functions. Remember, sine's reciprocal is cosecant. It means if sine is opposite over hypotenuse, cosecant is going to be hypotenuse over opposite. The reciprocal just means you take the fraction and flip it. If you have something like 2, the reciprocal would be 1/2. If you have root 3 over 2, the reciprocal would be 2 over root 3. That's how I do things. So I'm going to find the sine value. That's nice. Sine value is root 2 over 2. I'm going to flip it. Okay, the sine of pi over 4 is root 2 over 2. Cosecant of pi over 4 would be 2 over root 2. And multiply the top and bottom to rationalize this. And I get 2 root 2 over 2. Well, those 2's cancel. I just get root 2. It's fine. Just stay out of this so you don't get on camera.
The last, this box, I just need what we're doing on
Cool.
Thursday, Friday, Thursday. Sorry.
So just watch the lesson video and the homework video, do the homework, be ready for the quiz next class.
Awesome. Thank you.
Yep. Secant pi over 3 is the reciprocal of cosine. So same thing with this with cosine. Pi over 3, tall, side lengths, cosine 1/2, secant 2. Cotangent is reciprocal of tangent. This is easier to show if like tangent is opposite over adjacent. Cotangent is adjacent over opposite. I'd go straight to x over y versus y over x. pi over 6 over here. Opposites 1/2. Adjacent root 3 over 2. Adjacent over opposite, not opposite over adjacent. Adjacent over opposite. Keep, change, change. Is that what they say? Dividing is the same as multiplying by the reciprocal. You just get root 3. Five pi over 6. How did I get that? 6 pi over 6. Subtract a pi over 6. If you haven't figured that out yet, then stop watching and try it yourself. Okay? If you are just waiting for me to put up where things are and you don't know where they are and you haven't figured out, stop watching this video. You should be doing this by yourself. Okay? Hopefully this is just helping you. Subtract. Secant's the reciprocal of cosine, so let's find the cosine. It's negative root 3 over 2. So this is negative 2 over root 3. We got to rationalize. Multiply the top and bottom by root 3. You can come in. You get negative 2 root 3 over 3. They don't want to come in. 4 pi over 3. I know where 3 pi over 3 is. 4 pi over 3 is right there. That's horrible. That's fine. It's taller because it's a 60-degree angle. How do I know that? 3 pi over 3 plus a pi over 3. Both negatives because I'm going left and down. Cotangent adjacent over opposite. Negative times a negative is a positive. Simplifies to 1 root over root 3. Rationalize to get root 3 over 3. Yeah, come in. I'll sign. Come in. You need me to sign something? It's Friday.
Yes.
So be ready for your quiz Tuesday. Thanks.
Thank you so much.
Yep. Good luck. 7 pi over 6. Going left. Going down. Cosecant reciprocal of sine. Flip sine. Sine's negative 1/2. Flip it. Man, some pi's just don't show up. Cotangent 11 pi over 6. Right there. It's 12 pi over 6 minus a pi over 6. Minus is clockwise, not going down. It's clockwise versus counterclockwise, not up versus down. That gives us our short with the longer horizontal side. Adjacent, I'm going down, so that's negative. Adjacent over opposite is cotangent. Adjacent over opposite. Two pi over 3. I know where 3 pi over 3 is. Subtract 1. Let's be right there. To the left, up. Longer side. The vertical side, because we're going at a 60-degree reference angle. Secant is the flip cosine. Flip cosine. Cosine negative 1/2. Flip it. Cosecant 5 pi over 3. Go all the way around to 2 pi. That's 6 pi over 3. Subtract pi over 3. 5 pi over 3. Down. Cosecant is the flip sign. Sine is negative root 3 over 2. So negative 2 over root 3. Let's rationalize. All right, to the extremes. Okay. These are pretty easy. There's multiple ways to think about it. But it's kind of consistent with what we just did. Remembering that cosine of an angle ends up being the x distance. Okay? How much do you go left or right? You could also think about it as the x coordinate of where you are located on the unit circle. I like to think about it as distances. Sine is always the y, the vertical distance, the up and down. The x is the left and right. The y is the up and down. Okay, pi over 2, 90 degrees. If we're talking about a unit circle, pretend that's a circle. We know I've gone up 1 to get to this circle of radius 1. Up 1. That means the sine value is 1 at pi over 2. Do I go left and right at all? Well, if I start at the origin, no. Like, I don't go left, I don't go right. There's no x distance. That's why I say the cosine of pi over 2 is 0. Some people in the past were taught, hey, this coordinate is 0, 1. Problem is people forget like the coordinates or how to do it or order of things. And they're like, oh, cosine's x, sine's y. You could do it that way. I don't like to do it that way. Okay, sine of 3 pi over 2. Okay, on our unit circle, pretend that's a circle. 3 pi over 2 is down here on the bottom. I think just froze. All right, here we go. How did I get to this location on the unit circle? I went down 1, right? Well, going down is like negative 1. Okay. Since I don't go left or right at all, cosine 0. But since I go down 1, vertical, the y distance, negative 1. That's what I do. Tangent. Tangent of an angle, opposite over adjacent, y over x. Okay, let's think about it. Pi. To get to pi on the unit circle, I go to the left 1. Okay, left 1. Do I go up or down at all? No. I don't go up or down at all. But I do go to the left 1. 0 over negative 1 is my answer. That's just 0. How many times does 1 go into 0? 0 times. 0 times negative 1 is 0. So you're allowed to divide 0 by a number. You get 0. That's good to know. 2 pi. All the way around our circle over here. What happens? I don't go up. I don't go up at all. I do go to the right. Go to the right 1. Sine. Ups and downs. Y's. Zero is the same location as 2 pi. Different angles, but they're coterminal with each other. Do you go up or down at all? No. Do you go to the right? Yeah, I go to the right 1. Cosine is the x distance. It's the right and left. I go to the right 1. Cosine of 0 is 1. 3 pi over 2. Down here. Okay? If you haven't tried this yourself, it's time to try it. You don't go to the left or right at all. But you go down 1. So consider that y distance negative. Tangent, opposite, over adjacent, y over x. Y, down 1. X, 0. What's this, 0? You are not allowed to divide by 0. It's impossible. How many times does 0 go into -1? Let's see, like, how many times does 8 divided by 2? How many times does 2 go into 8? 2, 4, 6, 8, 4, right? How many times does 0 go into 1? 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0. It's not even infinity. You'll never get there. It just can't be done. So you're not allowed to divide by 0. Dividing by 0 is not allowed. That's undefined. Cosine pi. Pi, 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 pi. Over here. How did you get to the unit circle? How did you get to the unit circle at the angle of pi? Well, I went to the left one. It's like -1. I don't go up or down at all. Cosine x left 1. Boom. 9 pi over 2. Where's 9 pi over 2? 8 pi over 2 plus a pi over 2. 8 pi over 2. 4 pi. 1, 2, 3, 4. Plus a pi over 2. It's right here. Am I going up or down at all? Yes, I'm going up 1. Am I going left or right? No. I'm just going up. Sorry. 1. I'm looking for sine, not cosine. Tangent of 0. 0's over here. I go to the right one. I don't go up or down at all. Tangent y over x. This is it. Cosecant. Let's find the sine value. Flip it. Pi over 2. Go up 1. Sine value is 1. Flip 1. Well, how do you flip 1? Well, 1's just like 1 over 1. So flip it. Still 1. Cotangent, 3 pi over 2. 3 pi over 2 is down here. I go down 1. I don't go to the left or right at all. So, cotangent, x over y. X is the horizontal, y is the vertical. X over y. 0 divided by anything is 0. Pi. Here. How do you get there? I go left 1. It's like -1. I don't go up or down at all. Secant. Cosine flip. Cosine 0. Flip 0. Is it 0? Let's see. 0. I guess you can write this as 0 over 1. What happens if you flip that? Oh, hold on a second. Cosine. Oh my gosh, I'm wrong. What am I doing? Teachers make mistakes too. Cosine is the left and right. The left and right is -1. Flip -1. You still get -1, however you flip it. Silly. Secant 2 pi. Same deal. It's going to be 1. I go to the right one. I don't go up or down at all. So take 1, flip it, still 1. Cotangent 0, adjacent over opposite. 1 over 0, undefined. Cosecant 3 pi over 2, 3 pi over 2, down 1, left and right 0. Cosecant is sine flipped. Sine is -1. Flip it, it's -1. I need to get something where it's like 0. There we go. Cosecant pi. Here's pi. Left 1. Up, down, 0. Cosecant is sine flipped. All right. Sine of pi, 0. Flip 0, 1 over 0, undefined. Okay? Why do I say 0 is 0 over 1? Well, 0 over 0 is actually impossible. You don't write it 0, 0 over 0. It's actually because you can think of it as like opposite over hypotenuse. And you can think of this as being a triangle with the hypotenuse is 1. If you want to. Don't do it if it confuses you. I like doing it this way. It's less confusing. 9 pi over 2. Let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh, we were already here. Up 1. Left and right, none. Cotangent, x over y, adjacent over hypotenuse, 0 over 1, 0. Secant, 0. It's going to be 1. I'm just going to write this down. Okay? All right. Hope you enjoyed your first homework video. I got to go pick up my kids. Later.